Okay, today we're going to look at the chemical properties and the patterns in the periodic table, specifically in group 2 in the alkaline earth metals. If you haven't looked at the video for the alkaline metals, the group 1 metals, I'll post a link in the description below. You should go watch that first and then come back here and we'll look at the alkaline earth metals. So if you need to do that, go ahead and pause the video and I'll see you when you come back. All right, first thing we're going to do, like I said, is we're going to look at the chemical properties. We're going to look at some patterns in the periodic table. First things first, though, we got to make sure for safety. So gloves on. We are going to be working with some fire today. I have my burner here. We are going to be working with some acid today. So I want to make sure that I am well protected. So I've got my gloves and I'm going to go ahead and put on my goggles as well. So let's take a look at the metals that we're going to be investigating today. There are two group 2 metals. Again, group 2 is called the alkaline earth metals. So we have two metals today that we're going to be looking at. The first one is magnesium. So here is some magnesium. Okay, a silver colored metal. Now we remember with metals that they have a luster, they're shiny, they conduct heat, they conduct electricity, and magnesium is a good example of a metal. Okay, so there is magnesium. The second metal we're going to be looking at today is calcium. So here's some calcium. Now, when you first look at calcium, you might see that it's kind of dull, okay? But that's because calcium has reacted with the air. If I take a piece of this and I rub it on some sandpaper, okay, you can quickly see that it is shiny. It does have a metallic luster. Okay, so remember, calcium, just like magnesium, is a metal, conducts heat, conducts electricity, has a metallic luster. It's malleable, it's ductile. So we have magnesium here and we have calcium here. Okay, and we're going to look at some of their chemical properties and what they have in common. Now remember, both of these are group 2 metals. They're alkaline earth metals, which means they have 2 valence electrons. They are also going to have an oxidation number of +2, meaning they're going to lose those 2 valence electrons and become positive and have a charge of +2. So let's go ahead and take a look at some of these properties. So in my test tubes here, again, this is going to be magnesium right here, and this is going to be calcium. We're going to first start with the reaction with water. So I'm going to go ahead and take some distilled water and add a few milliliters of distilled water into my test tubes. Now the reason we use distilled water is because distilled water doesn't have any minerals in it. It's just the water. So as you can see, nothing in there but water. And we're going to use an indicator in our experiments today, in our activities today. This indicator is called phenolphthalein. It changes color. It's clear right now, and it changes to a pink color in the presence of a base. So what we're going to use it for today is an indication that a chemical reaction has happened, that something has changed in our test tube. So I'm going to go ahead and add 2 or 3 drops to each test tube. Okay. Mix that up real well. And you can see there's no color change. It's still clear, still colorless, nothing's happened. The reason I have my burner here today is we are going to produce a gas in our test tubes, and we're going to use what's called the glowing splint or the flaming splint test. It's the same thing. I use those terms interchangeably. So I'm going to take a flaming splint and I'm going to put it into my test tubes as I'm producing this gas. If it pops, that tells us that it's hydrogen gas. If the flame then gets bigger, that tells us that it is oxygen gas. Okay, so that is what we're going to use the flame test for. So I am going to go ahead and put the metals into our test tubes, and then I'm going to light my burner and do my flame test. I'm going to try and see if I can put the same amount of calcium and magnesium into our test tubes, because I'm looking to see which one reacts faster, which has a better reactivity. The more reactive the metal, the faster it's going to react. So I'm going to try to get these in at the same time. So again, this one is calcium, this one is magnesium. So let's go ahead and see what happens here. So already you can see the color change here, and I don't know if you can hear that, or you can see the bubbles and all of that gas that's being produced. You can see a little bit of color change here in the magnesium, but not much. Okay, and now let's go ahead and do our flame test. So I'm going to go ahead and turn on my burner. I'm going to light my stick. And see if we can get a good reaction here. Oh, I don't know if you heard that. We probably aren't going to get one from the magnesium. No. I have never been able to get a good sound, a good pop out of the magnesium when just using water. See, and we can get a little more there. That popping sound tells us that it's hydrogen that we're making. Okay? So again, if we go ahead and look at these again, looking at the color change, clearly the calcium reacted faster than the magnesium. If you just look at the difference in colors, this one is definitely purple. This one you can kind of see right at the bottom. It's starting to change purple, but not very quickly. Okay, here is calcium, this is magnesium. Clear color difference between them. You can see the bubbles. You might even be able to hear the bubbles being produced with the calcium. You might not be able to see the bubbles or hear the bubbles. There are bubbles, just not very many with the magnesium. It is reacting just very slowly. So calcium is definitely more reactive than magnesium is. Okay, that's our first part. Now go ahead and pause the video, answer the questions that you have there, and then we can move on to the second part where we look at the reaction with acid. All right, now as far as our reaction with acid, we're going to take the same metals and we're going to, instead of putting them in water, we're going to put them into a solution of hydrochloric acid, 1 molar hydrochloric acid. Okay, this is the same acid that's in your stomach. So this would be analogous to, this would show us what would happen if we ate these. What would happen in your stomach? Now you shouldn't do that. Do not eat calcium. Do not eat magnesium, at least not in their elemental form. And this will show us why we shouldn't do those things. So I'm going to put a few milliliters of hydrochloric acid into my test tubes here. Okay. Then I'm going to add a little bit of my indicator, of my phenolphthalein. Mix that up. Again, no color change, should still be clear. And now I'm going to add my metals. Now, just like before, I'm going to try and get the same amount so we can get a pretty good comparison as to which one reacts faster. All right, so I've got my calcium over here and my magnesium over here. So let's go ahead and put them in. So 1, 2, 3. Okay, again, production of gas, you can see the bubbles. Okay, now while that's going, I'm going to get my flame test ready. Turn on my burner so we can verify that this is indeed hydrogen gas that we're making. Again, we should hear a pop for hydrogen. Ooh, that was a good one. See if we can get one over here. Ooh, that was a good one too. Now, if you could hear which one was louder, that would tell us which one reacted better or reacted quicker, had more reactivity than the other. The louder the sound, the more reactive the metal is, because the more hydrogen gas we're producing. So let's see if I can do it again. I'm not always able to get it a second time, but let's see if I can get it again. So again, this, let's see if my stick will stay on fire. So this is calcium, and then this is magnesium. Yeah, see, I might not even get it. There it is. Okay. So there's our flame test. So we've confirmed that we are indeed making hydrogen and that the calcium made more than the magnesium did, meaning that the calcium is reacting faster because I'm producing more of the gas. Now they're still reacting, if you can hear them, and you can see they're still producing bubbles. I'm going to try to mix these up a little bit. And you can see at the bottom, hopefully you can see this, again, this is the calcium. It's starting to turn pink. Slowly, but it's starting to turn pink. If you look at the magnesium, there is no pink at all in here. Still lots of bubbles. It's still reacting, but I mean, my calcium is just about gone. There's not much calcium left in here. And as I continue to mix this up, oh, there's the color change right there. So again, this is my calcium, this is the magnesium. You can clearly see which one is more reactive and which one reacts faster. Okay, so that's the activity today. There we've looked at some of the chemical properties of 2 of the alkaline earth metals, group 2 metals, and you'll be able to answer the questions at the end of your lab. If you need anything, if you're not sure, if you have any questions, let me know. Otherwise, I'll see you guys later. Bye.